Hi, this is Richard C. I'm a math tutor here at Wyzant, and we're going to be answering a question submitted by a student who is trying to figure out the best enclosure for his llamas. And I'm going to start off with a little sketch of the situation where there's a river on the property, and then the enclosure is going to be built along the side of the riverbank. And the length of the enclosure is going to be parallel to the river. So that would be the length here. And then these would be the width and the width. And he wants the enclosure to have the largest possible area. Now we know he has bought 1,600 meters of fencing. So L plus 2W is 1,600. And we know that the area is going to be length times width. And so we're just going to substitute out the length. You can see the length is 1,600 minus 2W. And that's the length right there. And then we just put the width here. So now we have a single equation. And if I wanted to, I could express this as a function of width. The area is a function of width. And I can distribute that W if I wanted to. So I'd get negative 2W squared plus 1,600 W. And that W is not coming out too well there. It's conflicting with this video box. Sorry about that. But it's negative 2W squared plus 1,600 W. Okay. Now, I'm sure everybody can recognize this as a parabola because it's a quadratic equation. It has a second degree equation here. And if we wanted to find, here's the width here, and here's the area here. If we wanted to find the area curve for the area, we can set this to 0 up here, set the area to 0, and find the two intercepts. So this means W itself would be 0, and so when W is 0, the area is 0. And then you can see if if W is 800, then this factor becomes 0. So 1,600 minus 1,600 is 0. So the other intercept here is going to be at 800. And we know this is a parabola opening down because the leading coefficient is negative. And so we can do a quick sketch of this parabola. And it looks something like that. So now we know from symmetry that the vertex of the parabola occurs at 400 here. And so our solution is that the width is going to be 400. Now they also want to know what the length would be. Well, the length can be found this way. When W is 400, this is going to be 800. And so the length would be 800. So that's our solution. Our solution is to make the length 800 meters and make the width 400 meters each. And that would give us 1,600 meters of fencing and would also give us the maximum amount of area for that enclosure. And we're not being asked what the area is, but you could just multiply. If you were asked, this would just be length times width, which would just be 800 times 400. So that's it. It's a fairly quick and easy problem. Once you kind of just draw a diagram, whenever you're working with a word problem, it's always a good idea to draw a diagram. And then just work with what you're given and set up some equations and solve. the student here thought this might be a calculus problem, and it's really, you could solve it with calculus, but it's a fairly simple situation here with a parabola. So I just decided to use algebra. Okay, so that's it for this one. I'll see you next time. Bye-bye.